Back. It's been, I hope, a good spring break for you. We're going to talk today about logarithms, but first I want to remind you what we did just before. So before we got into these logarithms, we would get something where maybe the bases were the same, and we can compare those exponents, like this 2x minus 5, I can compare to the x minus 7 part right here. And then I could go ahead and solve by, of course, subtracting x from both sides and adding 5 to the other side, and I would get that x equals -2. We would do something like that. If the bases aren't the same, then I had to make you, or had to invite you to go ahead and change those bases. Like 32 and 4, both are multiples of 2, so I could take 32 and change them to 2 to the 5th, and 4 would be 2 squared. But now remember, he is to the power of 3x, so that would be the same as saying 2 to the 5th equals 2 to the 6x. And then I could go ahead and compare those exponents where 5 and 6x would be the same and divide by 6, so that x would be 5/6. Last, if I had the e, now e is a number, it is 2.718, so on and so forth. I can compare those exponents, so 2x equals 5x minus 6, and then if I go ahead and I subtract the 2x but add the 6, I will get 6 equals 3x, and then I would divide by 3, so that 2 equals x. So I hope that you remember that's where we're going. But what if I can't compare the bases? What if I can't work that? Well, we've got another way that we can talk about these exponents, and it's called logarithms. So logarithms are a way to talk about exponents. What I want you to notice is that if you have a base to an exponent, and that will equal some sort of answer, we can rewrite that as log with the base down here. The answer is next to that, and that will equal the exponent. That way, our focus is all about the exponent right there. Something like this. So I've got 3 to the 4th equals 81. Well, I can change that to log form by saying log base 3, because 3 is my base. The answer goes next of 81 equals the exponent, which is 4. So I can rewrite this. 6 to the 3rd equals 216. That means that my log has a base of 6. The answer, 216 goes next, is equal to the exponent. There's the 3. So that, then again, my exponent is the focus of what I'm looking at. So 64 to the 1/2 power is the same as log base 64 of 8, because that's my answer, equals the exponent of 1/2. See how we're going to work those? Now something you need to know too is that every time you see log by itself like this with no base, that is the same as saying that we have log base 10. And another way to write log of that funny number e, we call it the natural log, so we'll see ln. If you look on your calculator, you'll find those buttons on your calculator. The log and the ln, you'll see those right there, which we're going to worry about later. Okay, so let's see if we can go ahead and chase this up. So logarithms, again, a way to talk about exponents. So if I see that I have log with no base, basically that's telling me I have a base of 10 right there, with 10,000 as my answer equals 4, I can change that to the exponential form of 10 to the 4th power, because this is my power, equals 10,000. Log base 6 of 216 equals 3 means my base is 6, my exponent is 3, and my answer is 216. Okay, log base 2 of 256 equals 8 tells me that my 2 is my base, 8 is my exponent, and 256 is my answer. And then last, if I have ln of 54.60, my base here is going to be e. So that tells me e is the base, my power is 4, and my answer is 54.60. So that's what we're doing today. We're learning how to go from log base to exponential form, and from exponential form to log base.